Hello YouTube and welcome back to the Vinny G channel, a channel about everything and nothing. Okay, I've started looking at the design for this OZMO, OZMO, Oz short for Australia of course. So I've come up with a different variation for the power source and I'll explain why. These are 18650 2500 milliamp batteries, right? So technically but they're only 3.7 volt. Having three of these in series to raise it to 14 volts plus is going to ergonomically take up a bit of room, as you can see. So it's going to be quite round. Now you've got obviously a tube kind of device that's going to be around here. You know, it's going to have 1.5 mil wall thickness maybe, and it's going to have some kind of aluminium bracing in there to machine a base plate for the X motor. The X motor is obviously your tilt, right? So in using these batteries, you need circuit protection, battery protection, and you realistically, to charge these batteries, you're going to need a balance charger. I don't want to use a balance charger. I want to make it as simple as possible. I just want to plug my generic phone USB cable into my mobile charger, into my laptop, whatever, and just charge it. So I've selected some components and my cost is rising quicker than what I thought. The reason I wanted to use these batteries was because I've got them. I've got quite a few of them, right? But in using those batteries, the cost gets offset. This is part of due diligence on a project. This is how you'd go about it, right? You look at your component, you look at what it's going to cost, and then you look if you can do it cheaper, and you find how you can do it cheaper. And you look at the safety aspect of it, and there's a whole lot that goes into the design of something like this. And I can understand why it's major companies like DJI that have a whole factory, a whole team of engineers and all that do it. When it's a shit kicker like me, it's a totally different ball game, and I'll explain to you why. So we're just going to go over to the computer. I'll do screenshots now, and I'll have the camera running again, and we'll take it from there, and I'll show you what I've selected and why I selected it. Before we start with the CAD software, okay, here's the battery I've chosen. It's a 3.7 volt 600 milliamp hour battery, and it's $895. I need 14 volts total power at the motors, at least a little bit less might do it, I don't know, see how I go. But it has a 3.7 volt output, so we need to kick it in the nuts and make it scream a bit more. So we're going to use the buck booster, basically a power converter. Now this little potentiometer up the top here is how we control the output voltage, which is from 1.2 volt to 3.5 volt. Minimum voltage input is 5 volt to 32 volts, but 3.7 volt will be plenty. It will just reduce the life of the battery a little bit. So here's the USB charging device. As you can see, it's pretty optional. You could connect a positive and a minus here if you had to, but we're not going to use that. You're just going to be putting a cable in here, and so the battery will be charged from here, and the power from the battery sits in here and comes out these connectors down there, if you understand that. Here's the accelerometer, gyrometer, magnetometer, that little chip you saw in my video yesterday. So all these pins will get soldered to those points there, which will then be connected into the Arduino. I'm looking for some cheap motors. I found them. They're actually not a bad looking motor, these things. Obviously a bit of machining for the adapters to come around here, but I can take care of that. I have the lathe and the mill, so that's not a problem. These are $10 something each, but they total $29.94 for 3. Okay, so here's the PlayStation thumb controller shield, which is what will direct the motors and the camera. So there's the Arduino Micro I was talking about. I actually had a calculation up here for how long the battery life would be. Okay, and the 0.07 factor here is for whatever operating temperatures there might be. This was without the Arduino connected to it, so this is what I'm expecting to get for the battery life out of the whole setup, 3 to 3.5 hours. Plenty good enough, I reckon. Okay, what else? The Arduino. Okay, total price was $58.47 per unit for the electronics, and that includes all the shipping. So over to the extensive professional CAD software. So what we're going to have here is a USB charger. Okay, so your battery will be connected here. So I'll just put a battery, and then out of here we'll have the cables running to various things. It'll be running to, there'll be a split, so one will go to the buck booster, which is the power booster. This will be raised to, I don't know, 14 volts. I'll do the proper calculations. This is just a concept drawing. I'm yet to prove it, so bear with me. From the booster, you'll have 3 powers for the CAN motors. Okay, so your 3 motors will be powered by here. That's where they're going to draw their power from. They've got a 3mm shaft, which is all I need. Okay, so that's the motors. Now this will be connected to the Arduino. And from the Arduino you'll have the control lines into the motors, and you will have the thumb controller, which will connect that, in between here we've got the, I'll just call it the accelerometer, and that's all our components in place. So I haven't calculated my output volt, I roughly have, but yeah, so all this is going to fit into a handle. Now I'm going to have the bottom motor sitting here, a bracket will come out here, there'll be a motor here which will then control, there'll be a bracket here coming out here, whoops, a bit over, which will control the yaw, which will be there, X, Y and Z. Okay, and this will go back into the handle like so. So I'm just going to copy this off whatever I find that's around at the time being the most practical device. Like my dad said, you ever want to make money, just find out what someone's doing and copy it and sell it better. Alright, so that's about it for the concept drawing. As you can see on my beautiful CAD software, we'll call this Vince CAD, and I hope you enjoy it.